The question is, if in is equal to integration of 10 to the power nx under the limit 0 to pi by 4 with respect to x, prove that n times of in plus 1 plus in minus 1, which is equal to 1, and hence find integration of 10 to the power 6x under the limit 0 to pi by 4 with respect to x. We have given that in is equal to integration of 10 to the power nx dx under the limit 0 to pi by 4. Then we have to prove this result. So now just look here, this is in is equal to this. So we have to first calculate what is in plus 1. So here instead of n, we have to put n plus 1. So therefore in plus 1 is equal to integration of 10 to the power n plus 1, because this n is replaced by n plus 1, 10 to the power n plus 1 x under the limit 0 to pi by 4 with respect to x. Now we can again break it. We know that we have already seen in the reduction formula of 10 to the power nx. If you want to find out the reduction formula of 10 to the power nx, we have to break into two parts. One is the n minus 1 part and another is the 2. So n minus 1 plus 2 is nothing but n plus 1. Hence 10 to the power n plus 1x dx can be written as 10 to the power n minus 1x into 10 square x dx. Again, we know that 10 square x is equal to, it is sec square x minus 1. So we can also put 10 square x is equal to sec square x minus 1. Now we open the bracket. So it will be integration under the limit 0 to pi by 4 of 10 to the power n minus 1 x into sec square x. This is the first part, and minus 10 to the power n minus 1 x with respect to x. So now we can again separate the terms. Integration under the limit 0 to pi by 4 of 10 to the power n minus 1 x into sec square x dx minus integration of 10 to the power n minus 1 x dx under the limit 0 to pi by 4. So now if we see this and if we compare with the equation number 1, so in place of n it is n minus 1. So we can write down this is nothing but in minus 1. In minus 1. So let us go ahead. Therefore, in plus 1 is equal to integration under the limit 0 to pi by 4 of 10 to the power n minus 1 x into sec square x with respect to dx with respect to x minus integration of 10 to the power n minus 1 x under the limit 0 to pi by 4 with respect to x. And we have already seen that this is nothing but in minus 1. And again, we can apply the same formula which we have already used in the last example. Integration of f of x to the power n into f dash of x dx, which is equal to f of x to the power n plus 1 upon n plus 1. So here n minus 1 plus 1 upon n minus 1 plus 1 under the limit 0 to pi by 4 of 10x to the power 10x minus, this is nothing but in minus 1. So if we substitute the limit, we are getting 1 upon n, because this plus 1 minus 1 will cancel. This will also cancel. 10 pi by 4 to the power n minus 10 to the power 0 to the power n. We can write down 1 upon n, 1 to the power n minus 1, 0 to the power 1 minus n minus 1 minus in minus 1. And this is nothing but 1. 1 minus 0 is 1. So we can write down 1 upon n minus 1 upon in minus 1. If we transpose this minus in minus 1 to the left hand side, we have in plus 1 plus in minus 1, which is equal to 1 upon n. And if we multiply whole equation by n, then we have n times of in plus 1 plus in minus 1 equal to 1. So this was the first result which we have to prove. So this is our first answer. Now let us find out the specific value of 10 to the power nx dx when n equal to 6. Now we have to find the value of integration of 10 to the power 6x under the limit 0 to pi by 4 with respect to x. From equation number 3, we have in plus 1 is equal to 1 upon n minus in minus 1. Now, we want to find out the value of I6. So here we have to put n equal to 5. So putting n equal to 5, 3 and 1, we have, let us first put n equal to 5. It will become 5 plus 1, which is equal to I6, and 1 upon 5 minus I5 minus 1 is I4. So the value of I6 is 1 upon 5 minus I4. But again, I4 is unknown. So let us try to put n equal to 3 in this same equation. So we have I3 plus 1, which is equal to I4, which is equal to 1 upon n means 1 upon 3 minus I3 minus 1, and I3 minus 1 is nothing but I2. Let us again try to find out the value of I2. For this purpose, we have to put n equal to 1 over here. So I1 plus 1 equal to I2, which gives us 1 upon 1 minus I1 minus 1, because n is equal to 1, so 1 minus 1, I0. So how to find the value of I0? So since we have n equal to 0, we have to put n equal to 0 in equation number 1. We have, what is n equation number 1? It is nothing but in equal to 10 to the power integration of 10 to the power nx dx under the limit 0 to pi by 4. So we have to put n equal to 0 over here. So this can be written as I0 integration of 10 to the power 0x under the limit 0 to pi by 4 with respect to x. So it can be written as pi by 4. So the value of I0 is pi by 4. So we have to substitute the value of I0 is pi by 4 over here. Then we get the value of I2. This I2 is substituted over here. Then we can get the value of I4. And then if we put the value of I4 over here, we can get the value of I6. So let us do one by one. So hence from equation number 3, 4 and 5, we have I6 is equal to 1 by 5 minus I4, 1 by 5 minus I4, but I4 is equal to 1 by 3 minus I2. So if we put 1 by 3, so this is minus sign, so it is minus 1 upon 3, and minus minus will become plus 1 by 5 minus 1 by 3 plus I2. But 1 by 5 minus 1 by 3, what is its LCM is 15, and this is 3 minus 5, so its value is minus 2 upon 15, plus what is the value of I2? The value of I2 is nothing but 1 minus I0. And again, what is the value of I0? I0 is pi by 4. And the next part, what is the value of this? Minus 2 by 15 plus 1 by 1. So it is LCM is 15. This is minus 2 plus 13 plus 15. So the answer is 13 by 15 minus pi by 4. Hence, the value of I6, which is equal to integration of 10 to the power 6x under the limit 0 to pi by 4 with respect to x is equal to 13 upon 15 minus pi by 4. So this is the desired result, or this is the desired value of I to the power 6. Thank you.